Okay, in this video, we will be doing lesson 6-3, where we look at similar figures and scale drawings. So similar figures have two main properties. The corresponding angles have equal measures, and the lengths of the corresponding sides are in proportion. Remember in lesson 6-2, when we were solving using proportions, we did our math in that cross product pattern. We will be using cross products again. So just remember that that means that you're multiplying top of the first fraction, bottom of the second fraction, and then bottom of the first fraction, top of the second fraction. Okay, similar to that image. All right, similar figures have the same shape, but not necessarily the same size. Oh, whoops. What happened to Miss Keel's paper? There we go. The same size. An indirect measurement is a process that involves using similar figures to compute distances that are difficult to measure. What that means is that we're going to use examples like how far things cast a shadow is going to help us figure out how tall they are, because it's a lot easier to measure things that are on the ground than perhaps how tall a flagpole is or how tall a building is. So indirect measurements are what they're talking about there. A scale drawing is an enlarged or reduced, so either gets bigger or smaller, drawing that is similar to an actual object or place. And then the last vocab, this symbol, which is like a squiggly line, it means is similar to. So when we're doing similar figures, they're going to give you trapezoid names or shape names with the letters, and then they're going to have that symbol, that squiggly symbol in between to say is similar to. So like for this first example, it says trapezoid ABCD is similar to, using that symbol, trapezoid EFGH. Find the value of K. So when we look at this, you can tell that AB and EF are essentially the same size on the similar figure, or the same side. You can tell that DC and HG are the same side on the similar figure. So when we're looking at that, we're going to be able to make proportions like how we did in lesson 6-2. So the part of this that you have to pay attention to is that you have to have one particular shape or set that you're pulling from for the top, and one that you're pulling for the bottom every single time. So on here they have 6 and they have 3. Notice that those are on the tops of the fractions, and they both come from this first ABCD trapezoid. Then they have left blank, and we're going to put the corresponding ones from the EFGH trapezoid. So 6 and K are the same side, so it would be 6 over K. And then 3 and 2 are the same side, So it would be 3 over 2. So do you see how they pulled from this trapezoid first for the top, this trapezoid second for the bottom, and then again this trapezoid for the top, this trapezoid for the bottom? And you're going to want to make sure that you have proportional sides. So like 6 and k are the same fraction and 3 and 2 are the same fraction, because this is the same side on the two similar figures and this is the same side on the two similar figures. Okay? Because AB corresponds to EF and DC or CD corresponds to HG. Okay, now we're going to solve just like we did in 6-2, where we're doing those cross products. So we're going to have 6 times 2 and k times 3. 6 times 2 is going to give you 12, and you're going to have 3k on the other side. You need to divide both sides by 3 to make it so that all that's left is the k, which means that side k is 4. So that side that is proportionate is going to be 4. If you think about it, that kind of makes sense too if you want to do like a check. This side is double this side. This side is double this side. So you can tell that you did it correctly. All right, when you are ready, go ahead and flip your paper over and we'll do the back. So a flagpole casts a shadow that's 5 feet long. At the same time, a yardstick casts a shadow that's 1.5 feet long. The triangle shown for the flagpole and its shadow is similar to the triangle shown for the yardstick and its shadow. How tall is the flagpole? So we don't know this, but we have similar figures because we have this distance, the bottom on the ground distance, and the bottom on the ground distance, and then we have a height versus a height. So we're going to set this up in the same way, making sure that the tops of our fractions are from the same image and the bottoms of our fractions are going to be from the other image. Okay, so that's, got to make sure you set it up that way. All right, so 1.5 would be over 5 because those are the bottom shadows for both of the images. And then 3 would be over x because we don't know how tall the flagpole is, and that would be the same side from those two images. Okay, we know that they are similar triangles, so that means that they are in proportion. So this is going to work to tell us how tall the flagpole is. So our first set of cross products is going to be 1.5 times x. Our second set is going to be 5 times 3. 5 times 3 gives us 15. We have to divide both sides by 1.5 so that we get the x by itself. And we end up with x equals 10. So the flagpole is 10 feet tall. You can do this without an image too if they give you a scale to use. So like this one says the scale of a map is 1 inch for 24 miles. Okay, so 1 inch corresponds with 24 miles. About how far is it between two cities that are 3 inches apart on the map? So they show you that you're going to do inches on top for the map and miles on the bottom for each fraction. So for the first one, we have 1 inch over 24 miles because that's the proportion that they gave us. And then on the other fraction, we have 3 inches because they said that towns are 3 inches apart over, oh, they use a D, over D for miles because we don't know how many miles it is. Then we're going to set it up the same way, doing those cross products. So we have 1 times D and 24 times 3. 1 times D is just a D, so we don't have to do any division on this one. And 24 times 3 is 72. So it's about 72 miles between the two cities. All right, so for the quick check number 1, they say that trapezoid KLMN is similar to trapezoid ABCD in example 1. Find the value of y. So remembering, so you don't have to flip your paper, I will draw that one again. ABCD had 6 here and 3 here. So you're going to set it up just like we did the example on the other side, taking into account that AB, the top side, is going to be the same as KL, DC, and NM are going to be the same side, and so you're going to set up your fractions and your proportions. You don't have a lot of room right here, so if you want to do it off to the side, that's fine. Go ahead and pause the video and do this one on your own, and then we'll come back together and check it. Okay, so I chose to use this trapezoid for the top of my fractions. So I set it up where I had, I'm going to do it off to the side over here, 6 over y, because those are the same side from the two pieces, equals 3 over 5. So again, 6 came from this one over y, which came from the other shape. 3 came from this one on the top, 5 came from the other shape. So you just have to make sure that 6 and 3 are both on top, y and 5 are both on bottom. Then you can do your cross products. You're going to have 6 times 5 equals 3 times y. 6 times 5 is 30 equals 3y. Divide both sides by 3, and you end up with 10 equals y. All right. A building 70 feet high casts a shadow of casts a 150-foot shadow. So 70 feet tall, 150-foot shadow, and that's just going to be to make it a triangle. Okay, that's one. A nearby flagpole casts a 60-foot shadow. So they don't tell us how tall the flagpole is, but the shadow is 60 feet. Draw a diagram. Okay, so we did that. So we have 70 feet high, 150-foot shadow. That's one triangle. Don't know how tall, cast a 60-foot shadow. That's our other triangle. Use the similar triangles to help find the height of the flagpole. So this is the part you're going to do on your own. You're going to set up your cross products and solve for x. So go ahead and pause your video. This is very similar to the one at the top of the page, and then we'll come back together and check it. Okay, so I'm going to pull from this triangle for the tops of my fractions. So I'm going to have 70 over x because those are the same side. And then I'm going to have 150 over 60. So again, 70 and 150 are both on the top. X and 60 are both on the bottom. 70 and x are from the upright. 150 and 60 are from the shadow. All right, to solve that, I'm going to do cross products. So I have 70 times 60 equals x times 150. 70 times 60 is going to give me 4,200 equals 150x. And I divide both sides by 150 so that I get x by itself. I'm going to get 28 equals x. So the flagpole is 28 feet tall. Okay, the distance from Atlanta to Macon is about 75 miles. On a map whose scale is the same as example 3, which was our 1 to 24, what is the approximate map distance between the two cities? So our first fraction we're going to set up is going to be that 1 over 24 equals, and then remembering that 1 inch was 24 miles, We know 75 miles means that 75 has to go on the bottom because we have inches on top and miles on bottom, inches on top, miles on bottom, and we put an X for that one because we don't know how many inches it's going to be because we're looking for the map distance. So you're going to solve this one, do your cross products, and then we'll come back together and check it. Okay, so for this one, we're going to have 1 times 75 equals 24 times x. 1 times 75 is just 75 equals 24x. Divide both sides by 24, and you're going to get 3.125 equals x. So the map distance is about 3 inches. All right, that's going to wrap up lesson 6-3, where we're looking at similar figures and scale drawings.